Okay guys, so welcome back to another video. So this is our third video in our retrosynthesis analysis series. Okay, in our first video we have talked about the introduction. We have introduced you to the basic terms and what are the disconnections and how you can think a retrosynthesis analysis problem. Okay, if you have not watched it, I highly recommend you to watch it. Like if you have the basic idea, then it's fine. In our second video, we have introduced you to the functional group interconversions, and now in this video we are going to do some example with like the most exam target example. Okay, so now our problem is this. This is our target molecule. Okay, this is our target molecule. So you need to introduce a retrosynthesis pathway for this target molecule, and you are given one of the reagents. This is one of the reagents you have. Okay, so there can be other reagents. You need to identify those things. Now you need to introduce a retrosynthesis analysis. Like in your analysis pathway, this should be a one reagent. Okay, now when you see this, you can see the NO2 groups has been removed, right? NO2 groups have been removed. So we have to do a disconnection through here. Now remember, okay, you cannot do the disconnection through here, right? So let me adjust this thing. So if you watched our previous video, our second video, I have talked about that the activation and deactivation of carbon rings. Okay, like in your process, in your retrosynthesis process, if you achieved a deactivated ring, like here, so if you remove this part and this part from your benzene ring with a disconnection, you are living with these two NO2 groups. NO2s are deactivating the benzene ring, so you are left with the deactivated benzene ring. So try to avoid the deactivated benzene rings because these guys doesn't have that much amount of reactivity. Okay, so always try to achieve a activated benzene ring. So that's why you cannot go through this pathway with the disconnection through these bonds. Okay, so you have to disconnect the NO2 groups. One thing is you have a better mechanism. Like if you disconnect through here, which means you are removing a NO2 group, you can attach a NO2 group into benzene ring with a proper mechanism. There is a very good mechanism for attaching the NO2 groups, and also by removing the NO2 groups, you can remove the deactivating groups. Likewise, these things are important, right? So always try to get those ideas when you do the problems. Okay, now first thing what I'm going to do is, okay, we have to remove the NO2 groups, but before that, here you can see we have a chlorine group here. So first let's do a functional group interconversion. What we will achieve is we will change our NPR2 group into a chlorine, and the CF3 is the same, the NO2 group is there, and then you can do the disconnection through here. Now you will left with these two syntones, and you have NO2 plus. So now when you introduce you to the synthetic equivalents, so these are the syntones, right? So you need to introduce to the synthetic equivalents. So let me draw it, right? Otherwise here we have the synthetic equivalents, CF3, Cl. So you know, like these are benzene rings, right? Benzene rings are naturally nucleophiles, so you just can remove these lone pairs. Okay, just ignore the lone pairs. You know what the synthetic equals for NO2 plus? We have talked about in our second video. We have talked about it. Okay? Basically, it's conc H2SO4 and conc HNO3. That's fine. So this is the final reagents we have, and now we can introduce the synthesis pathway. We have this reagent here. You can see we have obtained this reagent. We have chlorine and CF3. Then we need to attach the NO2 groups, so you can add conc H2SO4 and conc HNO3, which means you are attaching the NO2 groups here. Now you need to convert your chlorine groups chlorine group into a NPR2, what you have to do is HNPR2 and in high temperature. So this is basically a normal organic chemistry reaction, right? You don't have to know the exact mechanism, but you know to like take an idea about like what this, how to convert a chlorine group into NPR2. Likewise, these things you need to be remembered, okay? And then you can have finally the target molecule. So this is a pretty easy question. It's not a hard, it's not a big deal, okay? Now most of the time your question patterns will be like this. So this is a very simple question, right? This is a very simple one. So I think you should be able to do it by now with our knowledge we have. So the thing is like you will be given the target molecule and you will be given some hints, right? Likewise here. So one of the reagents is this. Likewise, you will be guided to a specific pathway. So otherwise it will be more tricky. So in our next videos, we will go with more advanced problems and more advanced approaches, right? So I hope you are okay with it. If you have any questions, feel free to comment below.